Hi everyone, I am Hasan Savran. I would like to introduce you to Azure Cosmos DB for all your operational database needs. Azure Cosmos DB is a fantastic database service that offers different kinds of database engines in one place. Whether you are into relational or non-relational databases, it covers you. It supports PostgreSQL, MongoDB, CassandraDB, Graph databases, Azure Tables, and its own NoSQL database engine, which is very easy to learn. Azure Cosmos DB can quickly adapt to your requirements and grow as needed. Let's start with the setting up the Azure Cosmos DB service and creating a database and a container in the Azure portal together. So I'm in the Azure portal, as you can see. I'm going to go and click on the Create a Resource button, then find the databases from the categories and find the Azure Cosmos DB in the list. For that, we are just going to go and click on the Create button. Then it looks like we have two options here. Those are the recommended APIs from the Cosmos DB. First one is Azure Cosmos DB for NoSQL. This is the native API of Azure Cosmos DB. And I will highly recommend this one for any of your projects, especially for the brand new ones, because this is always going to have the latest and greatest features of Cosmos DB. Next one is the Azure Cosmos DB for MongoDB. Maybe you already have an application and using the MongoDB database, but you are looking for a database service which is fully managed, or you are looking more features like global distribution or auto scaling. If that is the case, you can easily select this one here. All you have to do is just migrate your data from your MongoDB to Cosmos DB. And when your data is ready to go, all you have to do is really change your connection string and your application should be good to go. Well, in my case, I'm going to actually go and pick the Azure Cosmos DB for NoSQL. So I'm going to go and click the Create button here. Next, I'm going to answer a couple of really common questions for any service in Azure Cosmos or the Microsoft Azure. So the first one is a subscription. Second one is going to be the resource group. So I'm just going to go and select one here. And next, I need to give a name for my account. So let's call that Sovereign Web 09. And I don't need availability zones right now. This is the location of my service. Now, there's one important question here, capacity mode. And to answer that one, I guess the easiest answer for that is, for example, if you want to keep the provision throughput. Provision throughput is for applications or services with sustained traffic. And in any applications requiring predictable performance. If that is the case, you just keep provision throughput. Next option is serverless. Serverless is for applications or services with unpredictable traffic. Some of my dev and QA environments, I just picked the serverless because I don't really need sustained traffic for those environments. So I just picked those serverless. The serverless can be great. And really in the serverless, you just pay for what you, spend out there. Next option we have is the apply free tier discount. If this is the first Azure Cosmos DB you are creating, this option will be available for you. It is not because I have some other Cosmos DB accounts here, but if this is the first time, be sure that you click the apply here. This is going to give you 1,000 request units and 25 gig of storage for free. So you want to take that advantage for sure. So if this is available, be sure that you keep apply here. From here, I am just going to go and click on the review and create and wait a couple of minutes. Then it should be available to go. Then we will actually go and try some of the operations on it. And well, we need to create some database and containers first. So let's actually click create and continue. All right, it looks like my service is ready. So next step is going to be creating a database and containers under the database. For that, I'm just going to go to my resource first. And as you can see in here, if you click the Data Explorer link here, it's going to actually show you all the data. Since we have nothing here, I'm not going to see anything. To create a container, the container actually keeps all your data in it. So to be able to create that, first we need to create a database. When you click here, that's going to be the first question here, database ID. So let's say we are creating a web application, and this web application is going to sell some products, so it's the e-commerce web application. So for the database, I guess let me call Sovereign Web. That's going to be the name of my database. And share throughput across container. I'm going to uncheck this one for now because that means that you are going to, or the application is going to actually share the throughput, which is in UC here, among the different containers. So I don't like that one. I'm going to uncheck this one because I want each container be more flexible and have its own request limit. Now, the first container. I'm sure you're going to have some kind of data model. You might end up with a couple of containers. So for this demo, I'm just going to create a customers container, which is going to keep all our customers' information in it. So let's look at it again. Our database is Sovereign Web. Our container is the customers, which is going to keep all the customers' information. Next one, we are going to pick a partition key. Now, this is really, really important area. You really need to know your data and pick a partition key, pick a property which is very common in all of your filters. For me, I am going to pick the customer ID here because most of the time I'm going to have my customer ID. If I want to get information about the customer, I should have the customer ID. If I want to update, I should have the customer ID. So that's one of the most common properties. So I'm going to keep that in customer ID, and that's going to really easily group by all my data together because each customer ID is going to have, get partitioned, and everything should be really in balance when we do like that. Now, this is my partition key. Let's continue here. Next one, container throughput auto scale or manual. I'm going to keep this auto scale. What I'm really saying here is if my application is going to get busier, Cosmos DB is going to scale up my application to 4,000 request units. If nobody is visiting it, then it's going to go down to 400 request units, which is the 10% of this number. The request units, if I try to explain that quickly here, request units, whenever you make any kind of request from Cosmos DB, well, Cosmos DB is going to use some CPU, some memory, some resources to actually complete that request for you. And it's going to charge you X number of request units depending on how much resources it uses. So I'm going to pick 4,000 here as the maximum here as an auto scale. If you don't want auto scale, you can go manual, but you really need to be careful with that number because let's say we are going to have maybe like a sale next week, and we know that our application is going to be busy. Well, if you pick manual, it will be your responsibility to kind of come back here and scale up your application. And when the sale is done, you're going to come back here and, well, change it back. So I like the auto scale, so I'm going to keep it auto scale for that. Now I am actually ready to create my container. Let's click OK here, and this might take a couple of minutes, and my container will be ready under the Sovereign Web database. All right, it looks like our new database is ready. As you can see, I can see the database name here, and this is the customers where I'm going to keep all the customer information. So if you click here, you are going to actually see, if you want to see the data, right now I have nothing in it, or you can click items, and if there was any data, it was going to get listed here if you want to change any kind of settings on container, as I said before, if you want to scale up and scale down, if you want to change the manual or auto scale, everything you can do it here under the scale and settings part. Now, I think we are ready to insert some data here, right? So for that, I create a very simple console application I'm going to use, and I'm going to show you how to insert data to the customer's table or the customer's container. We are going to update a customer. We are going to delete a customer. And also there is a really much fastest way to kind of pull an object from Cosmos DB rather than querying, which is the point read, which I will actually demo that for you too. So next, let's actually do that together. I just created this very simple console application. And the first thing you need to do, doesn't matter, I guess, what is a console application, web application service, you need to include the Azure Cosmos DB's SDK from the NuGet. So since I'm using the C#, I just got the Microsoft Azure Cosmos. As you can see, you can get the latest version. And then we are ready to write some code. The first thing we are going to need is the connection string. So you can find these connection strings under the Azure portal, under your account, the Cosmos DB account. Under the keys, I believe, you can access the connection string from there. Just copy and paste here. Then we need to declare the Cosmos client. Cosmos client is really the main door that your application is going to reach to Cosmos from. So as you can see, I just passed the connection string here, and I declare my door. Then, well, we need to know the name of the database and the name of the container. As you remember, we created a customer's container, which is going to keep all our customer information. So currently, I have no data in it because brand new application and database and container. So I'm just going to create a fake customer here by using this function. So if I go and look at that function, I just have the customer object, and I'm just passing a couple of really simple information about the customer, the names, email, phone numbers, when it registered, and I have addresses. So I have one address under that, and also I have a payment methods. So those are the things that I want to track in my customer's container. Now, we are ready to insert this customer to the Cosmos DB. As you can see, I am first declaring my container. And to do that, I am using the Cosmos client. We are going to get the container from this database, and that is the name of the container. So this is the Sovereign Web, that's the name of the database, and container name is the customers. Then I am gonna go and actually use the create item async function. This function is gonna actually insert the data into Cosmos DB to this container that I just declared. As you can see, it just takes an object. In my case, it's the customer, and you need to pass the partition key which we declared when we were actually creating our customer. So this, you need to pass customer ID in here. From here, everything should go through, and this is going to actually insert the customer to our database. Next one is update. Update customer is really going to work this almost the same way. We need to get the container first and pass our database and container name. Then you need to update something. In my case, I'm just updating the name here. Then I'm going to actually call replace item async function. And this function takes the object. In my case, it's the customer. You need to pass the document ID, which is the customer ID here. And also you have to pass the partition key. So those are the three required fields for update to work. As you can see, as long as you have all these fields ready, this should work. And you will, in my case, I will update the first name of the customer. Another one is delete customer. So in that case, again, I need to declare my container. Then I need to call delete item async function and just pass the document ID. In my case, that's my customer's ID here, and the partition key of the container, which is in this case is the customer ID. That's how you delete a customer in my end. Now, how about retrieving data? You can retrieve data in two ways. One way is the query. You can write a query. As you can see, my query is very simple. I say select everything from C. What is C here? C is the current container, which is customers in my end. And I'm passing customer ID, and that is the parameter I'm passing, and I'm declaring the parameter here with parameter here. Then I am gonna actually create a feed iterator by using the get item query iterator, because, well, in this case, there's gonna be only one, but most of the queries returns much more than that. So that's why we need that feed iterator here. Then as long as there is a result coming from the Cosmos DB, we are gonna go in this loop here, and we are gonna read the next item, then put our customer in our customers object here. So in my case, there's gonna be only one, but if you're gonna have more than one, you're gonna have a list of customers or a list of other objects, whatever you like to, I guess, save in Cosmos DB. That's how the query works. As I said before, there is one more way to actually pull data from Cosmos DB, which is the read item async can do that with the point read operations. For point read operation to work, you need to have a document ID, and you must have the partition key. So if you have these two fields ready, and you want only one document, if you use the read item async, this actual operation is going to be much cheaper and faster than running a query. So I highly recommend you to use read item async as much as you can for a faster and cheaper results in Cosmos. In short amount of time, we accomplish a lot. So we have a new Azure Cosmos DB service, we have a new database and a container for our customers. We will check all the customer information in it. And we were able to kind of see some of the basic code for the basic operations in Cosmos DB. Now, let's talk about some of the best practices when it comes to the Cosmos DB. First one is the security. You can use the private endpoints to reduce surface attacks in Cosmos DB. Also, consider disabling key-based authentication and try to use roles, groups, or assignments for the security. Cost optimization is an important part too, because as your application is gonna grow, the number of requests is gonna get higher, and you're gonna have more traffic. So cost optimization is gonna be important. For that, you really need a good indexing policy. If you have a read-heavy application, you want to be sure that you are using all the indexes you need, and the ones that you don't use, you just exclude them. If you have a write-heavy application, then maybe you don't even need indexes, because mostly you are doing writing. So when you put indexes, actually your inserts and updates can get slowed down because of the indexes. So maybe you don't need the index if it's a write-heavy application. Partition key is very critical in Azure Cosmos DB. So take your time to find a good partition key, because as your application is going to grow and get larger, storage-wise and the traffic-wise, you're going to have more physical partitions, which is the different databases, and the partition key is going to be very important for your application. If you are doing a dev or test, you can use the Azure Cosmos DB emulator that is available. You can download it locally and execute it locally, so you don't even need a subscription to actually test some of those SDK calls. You can just use the emulator for that. Reliability, well, you can quickly increase availability by adding new regions to the Azure Cosmos DB. Spanning multiple regions prevents your accounts from being unavailable if there is a region outage. So when we actually talk about this topic, I want to actually talk about a little bit more because there are some exciting news coming up from the Cosmos DB. And for that, we actually have a new feature named Dynamic Autoscale per partition and per region. So as you know, today, what really happens here is, let's say we have an application and the application is in two regions. And it looks like each region has two physical partitions. One physical partition looks like is a hot partition and it needs 500 request units. Well, the problem here is everything is working fine, but when it comes to the cost, we kind of need to spend 500 for each physical partitions because that's how the billing currently works. So Cosmos DB picks the highest one, which is the 500, and just in this case, as you can see, multiplies with 4. So you need 2,000 request units if you do not have the dynamic autoscale. That's what's happening today. Well, good news is actually Cosmos DB is planning to change this with this new dynamic autoscale per partition or per region. So as you can see with this new feature, rather than paying 2,000, now this is going to actually cost you 900 request units with this new dynamic autoscale feature. So right now this is I believe, in the preview, so you can enable it, but I believe it's going to be available and generally available soon. So this is going to be really a game changer because that's going to make things more affordable, and you might be able to have, more regions later, and that will actually help you with the high availability. That's all actually I have for you in this video. Please follow me on the social media. I'm available mostly on the LinkedIn and Twitter, or X, I guess, whatever you like to call it. And I will have more videos coming up for you for the Azure Cosmos DB. Thank you for watching my video.